Hello everyone. So today we are going to do a project which is very famous and it is available on Kaggle, that is a Titanic machine learning from disaster. So let's go through it. So the data which are provided by Kaggle are split into two groups, that is a training set and a test set. The training set should be used to build your machine learning models. For the training set, we provide the outcomes, also known as the ground truth, for each passenger. Your model will be based on features like passenger, gender, and class. You can also use feature engineering to create new feature. So this problem is on a classification problem, and we are going to use a feature engineering further because some of the fields are in character, and we have to convert it into a binary so that machine can understand and we can train the machine. So the test set should be used to see how well your model performs on unseen data. For the test set, we do not provide the true ground truth for each passenger. It is your job to predict these outcomes. For each passenger in the key test set, use the model you trained to predict whether or not they survived the sinking of the Titanic. So our goal is to find out that how many are survived and how many are not survived on the Titanic. So this might be our dependent feature. So let's into a Python. So first we loaded our data, that is a training and test data. So we loaded the data. And we are doing the exploratory data analysis, means we explore the data more. So here we can see there are total 12 features are available in a train data set, and in a test set there are 11 features, which means the one which is extra in train set, that is our dependent feature, survived. With survived one is our dependent feature. So let's go and check what these features and all and data is all about. Those survived, and so if 0 is given, then he is not survived. You can see that 0 is given, he is not survived. 1 is given, yes, he is survived. P class means in which class the passenger is traveling. So he is traveling in third class, first class, third class. Name of a passenger is given, sex, male, female, and age. The age of passengers are given. SP means if a passenger is traveling with a SP, means siblings and spouse, then these features are there. If passenger is traveling with the parents and children, then these features, pouch is there, and ticket number, passenger fare according to the class which he choose, and cabin which is allocated to the passenger, and embark the destinations of the passenger. Means embark C means Cherbourg, Q means Queenstown, and S means Southampton. So let's go and do more analysis of data. Let's first find out that the missing or null value in the data. So just first we check that how many rows and columns are there in the test and train data set. So in train data set we can see 891 rows are there and 12 columns are there. In test data set there are 418 rows are there and 11 columns are there. These features are there. And in train data set, the age feature have some missing or null value. Cabin also have null value, embarked also have some null values, and we can sum up all the null present in train according to features. So in age there are total 177 null values are there. In cabin feature 687 null values are there, and embarked there are 2. Like that only we are going to test on a test data set that there are 418 rows are there total. So you can see that in the age there are 332 rows are there and rest others are null, not filled up, missing. And cabin also there are missing value, null value, and in embarked there are 4 right, 4 1. In fair there you can see that 1 is null. So we sum up all the null. There is 86 null values and age, 327 in cabin and 1 in fair. So we are going to remove the unnecessary column, which is a passenger ID, which will not give any effect on the dependent feature, which is survived is our dependent feature. So I imported the Seaborn to plot the graph between the dependent and independent feature. So first I created a function in which the bar chart is our function, and in it we type feature and it will plot the graph with against the dependent feature. So as we know, the axis of our independent feature and survived and dead is our dependent feature. So we can see that number of females count is more in surviving, and number of males are more in dead. So the female is survived more as compared to male, you can see. So let's say some more relationship, that if person is traveling with the parents and children, so if he is not traveling with parents and children, then he survived more as compared to the person who is traveling with one parent, children and all. So person who traveled with parents and children, so these are given. And if person is traveling in a class, first class, second class, third class, so if person is traveling in a first class, he survived more as compared to the second class. But the person who traveled in a third class, he died. The ratio is very high. In third class, how died dead. Likewise, we can see the sibling. If person is traveling with a sibling and spouse, so we can see the by chart that how many are survived and how many are not survived. So now we are going to do a feature engineering. So here we are going to convert some of the features in binary, which are there in a character, so that machine can understand the data well. So the first feature which we have is we are going to convert is sex, which is a male, female. So we will convert into the binary by 0, 1, and 0, 1 we are going to convert it. And in age there are some missing values are there, so we are going to take handle the missing value. How we are going to handle, we will look for the, and these all are in okay, this all are okay, ticket okay. I think we are going to drop this ticket because it's not going to affect on the dependent feature and survived feature. Fair, cabin also have null value and all, and also we will drop these features too. And in embarked there are SC and some missing values are there, so we will convert it into numeric and we'll handle the missing value in embarked feature. So we are going to do a feature engineering. So here I combine the training and test data, so I don't have to do the simultaneously conversion. I have to do a simultaneously conversion in train and test data. So because of that, I combine the train and test data. So now I kept the male as 0 and female as 1, and I plotted the graph with survived feature. So now you can see that 0 is for male and which is blue in color. So the male surviving ratio is less than as compared to the female, and you can see that the male died more as compared to female. So we converted into 0 and 1 now, and now you can check that yes, it got converted, that 0, 1, and you can cross check it. So now we are going to handle the values in missing value in age feature. So we are going to plot a box plot, and out of that we are going to take the median of it. So we are going to plot a box plot of age against the class the passengers are traveling. So like in first class, second class, third class. So in first class the U color is given and the median age is given. Like that in second and third class are given. So I'm gonna take a median and fill that missing value with that median. It gets filled with a 37, and if he's traveling in the second class, it gets filled with a 29 and respectively 24 with third class. And now you can see that there is no null value in age. Like this we can do for test data set. So we find the median of the test data set of age according to the class and fill that missing value according to the class. So for first class we filled 42, second 28, and third 24. And you can see if we add the null value that in age there is no null value, and again we combine training and test data set. So now we are going to handle the next feature, that is embarked. So we plot the graph of embarked, which is S, C and Q against the class, first class, second class, third class, and you can see the majority of people are traveling in towards Southampton, or the name Southampton. Okay, so we can fill the NA value by S because there is only two value and majority of people are traveling in a S, means towards N, means towards S, the destination. So we are going to fill the NA value in embarked as S. So now you can see that there is no null value in a embarked. And now we have to convert that S, C and Q in numeric. So we convert it into 0, 1 and 2. And now you can see that it get converted into 0, 1 and 2 so that machine can understand. Now we are gonna handle the next feature, that is a fare. So we again plot a box plot of fare and P class, and that we came to know about that majority of people are in first class, and we are gonna take the median of it. So we got the median is 52. So we fill the median value in a NA in fare feature. And there are some of features like name, cabin and ticket, which we are going to drop because it's not going to affect our dependent feature. So in last we are going to check that is there any null value or not. So now we can see that there is no null value in test data set, and also we are going to check in the train data set, is there null value? No, there is no null value. So now we are going to do a modeling part. So I imported the model, that is a cross validation score and logistic regression model for training the data set that we have. So I divided the data that of the trained data set. In X train data I kept only the independent feature and I dropped the dependent feature which is survived, and in Y train I kept only the dependent feature which is survived, and I applied the model on it and I got the accuracy of 50%. And after that I applied this model on a testing data set. So our main data is a test data set which we have, that is independent data are all there in it. So I dropped the passenger ID because in a train data set also we dropped the passenger ID. So number of features should be similar. And now we have applied the model on the testing data set. So, and I save the output in a submission.csv file where we can find that two features are there, passenger ID and survived. So let's see how the output looks. So here you can see that there is a survive ID and here is a survived, which we found by applying a model on a test data set. So now I'm going to upload this on a Kaggle and see how much score I get. So I submitted and I got score of 75. So that's it. Thank you very much for watching.